Good morning, students. Example number 6.2. It is a well known that a raindrop falls under the influence of the opposing resistive force. The latter is known to be proportional to the speed of the drop but is otherwise undetermined. So now here drop of the mass is equal to 1 gram falling from the height h 1 kilometer and hits the ground with a speed 50 meter per second. So now here first one is question is what is the work done by the gravitational force, and second one is what is the work done by the unknown resistive force. Okay, so now here in first case A is equal to the change in kinetic energy of the drops, change in kinetic energy of the drop del K is equal to 1 by 2 mv square minus 0. Okay, change in kinetic energy is equal to 1 by 2 mv square minus 0 means final kinetic energy minus initial kinetic energy. Now here in this case drop is initially in rest condition. Here we consider assume that 0 is drops is in rest situation in initial position. So final kinetic energy 1 by 2 mv square and initial is 0. So now is equal to 1 by 2 mv square into m mass of object here 1 gram. So now here into 10 raised to minus 3 in kg. Now into v square means its ground speed here. So v is equal to 50 meter per second. So 50 square. So here answer is equal to 1.25 joule. Okay, so change in kinetic energy from the h height and the speed of the object here drops is 50 meter per second and weight 1 gram. Okay, so now in second one here assume to z is equal to 10. Gravity of the drops here assume 10. Now work done by gravitational force. Work done by gravitational force. So now W is equal to mgh. Wg is equal to mgh. H here height, gravity, and now in this case mass of object means dropped mass. Now here so is equal to 10 raised to minus 3 m g 10 and here h is equal to we know that 10 raised to 3. Okay, 10 raised to 3. So is equal to answer is here 10 joule. Okay, answer is 10 joule. Now from the work energy theorem, here we know that work energy theorem in two parts. So del K is equal to work done by gravity and work done by the resistive force. So now here del G plus W R. Okay, so now here we have this one and this one. So now second portion here work done by the resistive portion. So WR is equal to W. Now in this case WR is equal to del K minus WG. So now value of del K 1.25 minus 10. So is equal to answer here minus 8.75 joule. Minus 8.75 joule. here resistive force is negative. Okay. Now 6.3 example. A cyclist comes to a skidding stop in a 10 meter. During the process, the force on the cycle due to the rod is 200 Newton and is directly opposed to the motion. So now here first one is how much work done the rod do on the cycle. Okay. Now second one is how much work does the cycle do on the road. So now here in the first case, work done on cycle, here work done on cycle by road is work done on cycle by road. On this case, work done by this friction force. Stopping force means opposite to the direction here. Okay, friction force opposite to this direction is friction force. So now here in this case, work done on cycle by the road, here main role friction force. So friction force work done by the road, WR is equal to now angle between the friction force and cycle wheel, here 180 pi means, so FD cos theta. So now here is equal to, we know that F is 200 Newton into 10 meter into cos pi into cos pi. So is equal to, in this case answer is minus 2000 joule. Work done on cycle by road. Work done on cycle by road. Now, so here how much work done the road do on the cycle. So first one is minus 2000 joule work done on cycle by the road. But here second one question, how much work does the cycle do on the road? Do on the road. So here we know that Newton's third law. Okay. So now here, but in this case, force is same. Force 200 Newton. But displacement of the road. Displacement of the road means D is equal to 0. D is equal to 0. So now in this case, work done by cycle on the road, work done by cycle on the road is equal to 0 because of F is 200 Newton. Displacement of the road D is equal to 0. So work done here on road by bicycle is equal to 0.